Hello, this is my pre-brief video for my third observation. I'm going to be teaching a lesson over, um, I'm going to be doing an activity over uh, function transformations. So moving vertically, horizontally, expanding the parent function. Basically, it's going to allow the students to see the transformations before we tell them and give them explanations as to what variables do what and what changes which parts of the function. So it's going to be kind of a self-discovery lesson. Um, I hope that when I explore, what I want to explore with this is I want them to be able to see how they can discover trends and how math kind of works with that. Um, because everything in math is a pattern, so I feel like as long as they are able to do, trying to find the right word here, as long as they are able to understand that the patterns formulate the way we think, I think that they will be able to kind of draw their own conclusions, and then we can talk about it as a class. Um, this is connected to the curricular standards of the district because it allows for the self-exploration activities so that the students can visually see it, as well as see it in um, equation form, as well as I will give a short lecture at the very end just to kind of summarize everything and kind of give them a concrete idea of how everything works. Um, and in my own pedagogy, I really want to explore my ability to kind of push my students to critically think and think about everything they're seeing and the patterns and trends that they're seeing. And I want to make sure that they can see that as well as I'm able to see it. To a certain extent, I understand that I obviously have more experience in this area than most students do. Um, and kind of the order is I'm going to introduce the activity. So I will show them what we're doing. I'm going to put it up on the projector screen so that I can show them how to export the image of the graph, how to put everything into Desmos, and then I will give them access to a classroom Google slide that they all have access to, so they will each be assigned. I've already assigned prior to the lesson. I've already determined what students will get what um, graph and everything like that, so that I don't have to do that. I can just get them rolling on the lesson and not waste time doing that. Um, and then once I give them access to slide, um, the slides, once I give them editing access, then they will, on their own, each input an image of the graph as well as note the whether it's concave up, concave down. A couple of the key features of the graph, I'm not going to have them do the domain and range because we're going to actually use the same activity again, the same slides to do that later on. Um, show them how it can affect the domain and range later on in another lesson. And then after we've all done that, we're going to go over it as a class up on the screen, kind of talk about it, how each one changed, and they're going to note that in their notes packet. And then I'm going to give a brief lecture over just kind of summarizing everything we covered in the class, and then let them work on the final pages of their packet. And then at the end of after the lesson, I just hope that they are able to see how the a, h, and k values of a quadratic in vertex form affect the way the graph will look in relation to the parent graph.